In this video, we will learn how to derive the indirect utility function from the given direct utility function. The question is, given utility function, utility is a function of two goods x and y, which is equal to x times y, and the budget constraint of the consumer is that price of good x times units of good x plus price of good y times units of good y should be equal to the income of the consumer. We need to derive the indirect utility function. Okay, so how do we solve it? So first we want to maximize the given utility function, that is u is equal to x times y, subject to the budget constraint, that is price of good x times price of good x times units of good x plus py times y should be equal to the income of the consumer. Okay, so to find out the indirect utility function, first we need to find out the demand function for good x and y. For that, what we do, we equate the marginal rate of substitution between good x and y, and it should be equal to the ratio of the prices. Okay, price of x upon the price of good y. So we know that it is simply the ratio of marginal utility of good x and marginal utility of good y, and it should be equal to the price of x upon price of y. Okay, so graphically it is simple. We have the given budget constraint. With the given budget constraint, we want to achieve highest possible utility, and it occurs at a point where MRS is equal to the ratio of the prices. Okay, so this ratio is the slope of the budget line, MRS is the slope of the indifference curve. So the tangency between them gives us the demand function for good x and y that we are supposed to find out first. Okay, so mux is the partial derivative, the change in the utility due to the change in the units of good x consumed, and muy means the change in the utility due to the change in the units of good y consumed. That is the partial derivatives of the utility function with respect to x and y should be equal to the price ratios. So taking partial with respect to x gives us y first, and similarly taking partial with respect to y gives us x should be equal to price of x upon price of y. Solving for y, we get price of x upon price of y should be equal to, rather it is equal to x. Now we plug this value into the demand function, rather into the budget constant, that means price of x times x plus price of y times the value of y is price of x upon price of y times x should be equal to the income of the consumer. So here we get this cancellation, px into x plus px into x is twice px into x should be equal to m. That gives us x will be equal to m upon 2px. Okay, so this is the demand function for good x. Likewise, we will get the demand function for good y will be equal to m upon 2py. How do we get it? Simply plug x is equal to this stuff into this equation. Okay, so these are the demand functions. To find out the indirect utility function, that is, let's denote by v, that will be a function of price of good x, price of good y, and income of the consumer. So indirect utility function will be derived by plugging the demand function for good x and y into our direct utility function. So we have, in place of x we have m upon 2px, in place of y we have m upon 2py. That means our indirect utility function will be equal to, so we have m square upon 2 into 2 is 4 px times py. That will be our indirect utility function. I hope I make myself clear and you find out this video helpful. If you like these videos, please share, subscribe, and give your valuable feedback. Okay.